He's with Karin Movili. He has published a book called The Disaster of the Digital School. And most recently, Le bonheur était pour demain, Happiness is for Tomorrow, I think, which was published last year. No, sorry, 2019, 2 years ago now. And maybe we'll hear more about that later. The way we plan to work this afternoon is, first of all, I'll invite Philippe to present to us, which he'll do for maybe 50 minutes or so. Anyway, the floor is his for as long as he needs. But after that, we'll have a good time for questions. So if any of you would like to put questions to Philippe, what we suggest is that you put your question in the chat box, which you'll find at the bottom of the screen. I'll be watching it along with colleagues from the Institute. And at the end of Philippe's talk, we'll invite those who've put questions to pose their questions to Philippe. If you would like us to pose the question for you, say so in what you write, and we will put them for you. But also during that discussion at the end, if you would like to raise a question, there's a facility, I think, to raise your hand in the reaction. If you raise your hand again, we'll watch out for you and do that. I hope that's all we need. Other than to say, I think all of you have. While Philippe's speaking, if we maintain our microphones on mute. I look forward very much to what you have to say, Philippe. The floor is yours. Katie, I think, is going to share her screen with you in a moment.
Yes, thank you very much, Chris. And when Katie will show the presentation, I will just have a few words to thank the Schumacher Institute. I'm very honored, of course, to be able to speak today here. So thank you for the organization, and thank you again, Chris, for after having translated the book to be able to find me such good opportunities to try to share a little bit my passion. And I would say my passion since 20 years is about non-renewable resources. Well, I come back to what I mean here. And since 20 years, I've been working as a consulting engineer, and also as a manager in different companies. And every time I kept this kind of passion of the usage of our techno-industrial system, the usage of non-renewable resources, and it has led me to become more and more skeptical or prudent about this smart promises that Chris was mentioning, that could of course help finding a way to extract from this dead end of climate change issues, resource issues, and pollution issues, where we've seen that humankind has always found a kind of technological answer, and then the answer would be again technological. And I will try to convince you tonight or today that it may be more complex because of this resources thing. I think the debate about resources, if we could have problems of scarcity, or which is in the title of my presentation, or if we should have a more cornucopian vision, cornucopia coming from Latin, and saying that finally we have always the abundance coming from the technological progress. It's not a new debate, and more than ever, and when I see the discussions, at least in France, I don't know how it is here in UK, but we have really these two visions more and more of people who are really saying that we will have no problem, and we just have to go to this hydrogen world or electric world, and etc., etc., and that we are just, our problem is just to be sure that in 2040 the new intelligent artificial intelligence will not be come over the humankind, and you have, of course, also an ecological part which is more skeptical, and obviously I'm part of this, but really based on, I think, on real facts, and not just the ideology. I think I'm coming at the end to more political questions now, but that are led by this mechanical vision, let's say, of the world and the usage of resources. So maybe we could go first to the next slide, Cathy, and let's talk first about what is this definition of non-renewable resources. Maybe it's quite obvious for you if you have already a kind of ecological pattern or background, but so you can see here a kind of logarithmic scale, so coming from a few days to up to 1 billion years, and you see obviously that some resources that we use, they are more on the left. That means if you draw a line with the human scale at about let's say 70, 80, 100 years. On the left, you have everything that can be renewed at a new human scale, and on the right, what is not renewable at a human scale. And that means that, of course, we are just plugging in a stock and not in something that can be renewed. Of course, when you are on the left, you can still exhaust also if you exploit the resource at a higher speed than the renewable rate, of course, the renewable rate, then you have, of course, a problem. But when you are on the right side, then you are sure to have a problem because you are sure that it will be exhausted one day. The question, of course, is when and under which conditions. So you see here that water, most of the water, let's say, is renewable. There are other challenges on water, which can be polluted, etc. But basically, water is here and is available, and there will never be a kind of, let's say, worldwide shortage. But of course, it can be fossil water. If you go in the middle of the Great Plains in the United States, or if you go into Libya or in Egypt, there we are exploiting for agriculture some groundwater table, and this is fossil water which has been accumulated, let's say, tens of thousands of years ago, mostly. Of course, food, when we talk about crops, even if it can be maybe a few tens of years if you go to grapefruits, all these kind of things, but it's, let's say, basically renewable resources. Of course, then come other questions of methane gas or exploitation of forests, etc. But basically, we are on the renewable side. Okay, same on hunting or fishing. Okay, sometimes you know that we exploit some deep sea species, which can be 130 years old. Of course, it becomes a bit strange to get this kind of fish in our plates, but it is the way the world is working for the moment. Forests, for the same, you can imagine eucalyptus forests, which are only 10 years or 7 years. Or 20 years for Douglas pine or this kind of thing. And then you can go to logging of ancient forests in Tasmania, in Indonesia, in Canada, and this is still happening. And we consume this ancient forest for producing mainly wood for construction and for paper. And of course, then we are on the non-renewable side. And then come our two let's say, heroes of the day: energy and mineral resources. And of course, obviously, these fossil fuels, firstly with coal. Coal is about 300, accumulated mainly about 300 million years ago, when at that time there were no mushrooms and no bacteria to be able to downgrade the new lignin molecule, and this wood accumulated once in the history of the world, and we are exploiting this now. Oil and gas is more something. Most of the gas and oil we are exploiting is something around 80 million to 150 million years, depends. There were various periods of formation, but it's again very, very far in the past that we are taking this accumulated energy of the sun indirectly. And then come mineral resources, and you see that there is a wide range of what we use. One of the most used resources is the salt that we use in the mineral chemical industry, which we use to produce chlorine, to produce soda ash that is used for many various types of activities, including glass manufacturing, etc., etc. But most of the mineral resources that we use, the metals, have been formed by the been accumulated, let's say, or I will come back to that, by the planet from, let's say, several million years to sometimes more than 1 billion year. For instance, the big most of the iron mines that we are exploiting now, they come from the Archean times. They have been accumulated by biological mechanisms, actually bacteria, and it was more than something like 700 to 1 point something billion years. So this is really our heritage that we are now exploiting. We can go to next page, Kathy. So what is this is first, I will show you a first picture of the play field of mineral resources. I think it's coming now, not on my screen at least, but maybe you know this table of Mendeleev. It's really a practical way, in fact, to speak about something which is even more complex than oil or gas, because we talk about 60 different metals, about 90 different chemical elements, and this is where we are what we are exploiting, and we since a few decades, let's say, with the development of the electronics industry, we are really using all of them during most of the history of humankind. We have used a few metals since the Bronze Age to the 18th century. It was only 6 or 7 different metals: gold, silver, mercury, iron, copper, and a few of them, tin also. And then we have been developing, of course, all our activities, and now we are using all of them. So there is a kind of color code here, but you shouldn't care too much. Okay, in the middle, you have the precious metals, so aurum, so gold, and number 79, for instance, and silver a bit above, argentum, and the platinoids, etc. And then you have also the rare earths in the bottom of the slide. I will come back to that a bit later. But it is basically the playground. Let's say about 60 different metals. Of course, they have very various geological characteristics. They have very various consumption and production characteristics. You have iron, of course, which is produced at more than 1.3, I think, or 1.5 billion tons per year. And you have some metals who are produced literally only a few tenths of tons. So you have really a wide range of specialty small metals, all the light blue ones here that you can see. And then you have the industrial metals, which are the dark blue, who are more produced, let's say, at a certain in million tons or tens of million tons or more. We can go to the next page, and now I think that yes, it's going faster. Super. I thought I should have anticipated a bit to signal to you, Katie, and thanks for your support. Here, so what is the problem, or is there a problem with this 60 different metals? Here again, be careful. It's again a logarithmic scale, but it's just a way to show how looks the chemical composition of the Earth crust for a few kilometers. Let's say what we could exploit, where can be our play field about finding resources and exploiting them to produce them in our industry. And you can see here that there are about 12 elements that are, sorry, the elements are in French, but okay, you will recognize them quite easily, I think. And you can see the 12 elements that we call abundant elements. They represent more than 99% of the Earth crust in weight. That means basically half of the rocks are oxygen, and a quarter of the rocks are silicium. So you see that we should never have a problem of silicium. You can see also that that iron, here it's written fer, iron and aluminium are quite abundant too. It's about 5% of the Earth crust is iron, and about 8% is aluminium. In all the clays, you find aluminium and silicium, for instance. And of course, it's not a surprise, but life has just taken most of these elements to build the basic molecules of our composition and so on, and not so much the rare elements. So sorry, I forgot to mention that the logarithmic scale here is in parts per million, what we call parts per million. That means if you are at one means that you have 1 part per million, or 1 gram for 1 million grams, which means 1 gram per ton. So you can see that here in the middle, between 1 and about 100, so that means 1 gram to 100 gram per ton of rock, you have most of the big industrial metals like copper, like lead, like zinc, like nickel, and also these small metals that we hear more and more, like cobalt, like lithium, vanadium, chromium, etc. These are called rare elements. Rare because they are, you see, it's not so much. It's 1 for 1 million in terms of abundance, but it's still a lot, and I will give you a hint on the kind of calculation. And then you have very rare elements on the left, and these ones is we drop to one part per billion. That means that you will find maybe one milligram of gold or platinum, or in a kind of average rock, let's say. And so that's not by chance that the gold or silver or platinum is quite expensive, quite precious. It's because they are at the end rare and not so abundant in the earth crust. So what's the issue finally? If we take copper, for instance, and that is about 50, 60 parts per million, that means 50, 60 grams per ton of rock. If I multiply this by 150 million square kilometers of all the continents, and I multiply by 1 kilometer of depth, then I find something like 1 million years of current consumption. So you see that if I would really be able to get all the copper that is contained on the first thin layer of the planet, I would have for sure for a lot of years, and there would be no problem of scarcity. So why do we speak about a potential scarcity? Of course, obviously, because I'm not gonna go in your garden and find the small copper that could be the few grams that could be in the earth of your garden. We will go to something different where the copper has been concentrated a bit more, actually not 50, 60 grams, but something like 15 to 20 kilograms. And this is what I'm going to call a mine. And this is where I'm going to exploit, of course, the copper. We can go to the next page, Cathy, and then we will come to a quite important principle, and this principle is what we call a reserve. What is exploitable by the humankind? And in fact, the definition of a reserve is that it's a geological resource that I have identified, I know it's there, and that I can exploit at the current technology and current price. That means that there are 3 dimensions to make the reserves vary. And you can see that it's, by the way, it's working the same for every geological resource, so including oil and gas. And that's why maybe in the 70s, people were saying we have 40 years of reserve. Today, we have still 40 years of reserves of oil. That's for these reasons, because these 3 dimensions are varying. Geological dimension first, because we can have, of course, we can find new resources, we can better explore the planet, etc. Then the technical dimension, which is quite important too, of course. You can, let's take what we call the shale gas, for instance. Of course, it's a new way to exploit with directional drilling, with fracking of the rocks, etc. So it's a way to have new techniques to exploit maybe more difficult resources. It's the same for the metals. Today, the new nickel mines, for instance, they are you extract the nickel from the rock by leaching it with some chemicals, and instead of making pyrometallurgy. So there is a progress, and with this you can have only a 1% nickel ore instead of having a 3 or 4% nickel ore. So you can progress like this and make the reserve grow with the technical progress. And the last dimension is the price. And of course, obviously, if the price is increasing, then you can afford to exploit less rich ores, or to go deeper, etc. And then that means the reserves will grow, and there is no limit. Of course, for oil there is a limit, because you cannot say if I invest 1 barrel of oil, I need to get more oil. If not, then I have produced no net energy. But for the metals, there is no problem. If you are able to pay me more as a geologist or as a mining industry specialist, I will find you the right metal. It's just a question of price. And the proof for that is that when you have an iron mine, you have about, let's say, 400 to 600 kilograms of iron in 1 ton of ore. If I go to my copper, then I have more like 15 to 20 kilograms. And when I go to a gold mine, I have only 1 gram to 5 grams in the same ton of ore. Why can I afford to go and dig my mine to just get 1 gram of gold? Because gold, you as consumer, you will pay me gold more than copper, and copper more than iron. So you will never hear anybody in the geological world saying we may be scarce. It's just a question of saying, give me the money, and then I can still go deeper. I can go to the oceans. I can go maybe to the moon and to the asteroids, everything you want. It's a question of price. And you will never hear either an economist saying we will be scarce, because the economists will say, yes, if there is tension between demand and offer, then the price will grow. And if the price grows, then of course, I will be able to to transform resources into reserves. And by the way, it will also increase recycling possibilities, for instance, or substitution possibilities. But there is something a bit more systemic, and we can maybe go to the next page, Cathy, and what is this issue? And then I think you can push a little bit on the button to make the arrows appear, no problem. The first point, oh, this is really strange transformation. I think you have an apple probably, Cathy, but that's not problem. It should be only a circle, basically. But what's happening actually is that our ancestors were not stupid, and we today are not stupid, and we go to the best concentrated reserves, and we exploit the most concentrated reserves and the easiest resources to extract first. And by doing this, what happens is that we are going to less and less concentrated minerals and metals, less and less rich ores, or we have to go deeper and deeper. And to do this, no problem, as we were saying, because we are also helped by the technological progress. But what happens is that then we need more and more energy, because you can understand that if with the same quantity of trucks, with the same quantity of explosives, etc., to exploit my mine, if I get 2 grams of gold, or if I get 5 grams of gold, of course, the energy content to extract these 2 grams of gold will be higher per gram, because I have just used exactly the same quantity. So there is a kind of clear trend. Of course, it depends on the different metals. It has a certain complexity, by the way. I will not enter in it today, but because there is also a kind of all the mines are polymetallic and there is a mix, etc. But basically, to keep it simple, let's say that there is a trend to less concentrated, to deeper mines, and it is consuming more energy. Of course, this is not a renewable energy, this one, because you can imagine that with trucks that are something like about 300 tons of ore weight, and they are gigantic. Their tires are bigger than me. Then they are not really equipped with electric batteries, and it's more fuel and liquid energy that we need to exploit all these mines. And this is the problem of this vicious circle coming in, because the energy is at the same time less and less accessible, as we know, and because there is the same trend on fossil fuel. Of course, there is plenty, but we need to go more and more deep, to go offshore, to extract some energy which has maybe less net energy content when we go to the asphaltic sands of Canada, etc., etc. So we need more. We have also attention not only on the resource side, not only on the metal side, but also on the energy side. And that's the bad news. This tension on energy is also requiring more metals. This is true for fuel, for oil, because if you go deep offshore, of course you need more metal investment per barrel produced versus what could happen in Saudi Arabia on the giant fields that have been discovered in the 30s and the 50s. But it's also true for renewable energy, because renewable energy being less concentrated, being more intermittent, having more intermittency, then you need to install a lot, and it's consuming more per kilowatt hour produced, more copper or more steel or more various types of resources. And then we can go to the next page. Cathy, thank you for your patience. Sorry for the small issue, technical issue. Here you see the Mendeleev table again, and just an example. It's not exhaustive, but you will with the renewable energies you will convoke different types of resources. So here the example with the solar panels. So okay, we've seen that silicium is very abundant, so no problem on the silicium, but you need more than silicium in the solar panel. You need a little bit of silver for the contactors. You need a little bit of copper. Sometimes you have a high yield solar panels, multi-layer panels that can contain indium, gallium, selenium, this type of thing. Then you can speak about hydrogen. You need fuel cells with platinum. You have in very big, very powerful wind turbines, you need some kind of neodymium and dysprosium in the magnets, in the permanent magnets that are in the devices that are transforming the mechanical move into electricity, etc., etc. So you have, of course, maybe more and more known the lithium, the cobalt, the nickel question, if you need to store this electricity. So you are mobilizing, we may mobilize more and more resources, and at the same time, we need to mobilize more resources. We may have more tension, and we should need to put more energy. So this is a bit a problem, because if we would look only on the geological side, we can say no problem. I can go deeper and deeper. If I have a lot of energy, no doubt I can do this Jeremy Rifkin world, fully covered of panels and wind, smart grids, etc. But I have a problem on energy. If I would have no problem on metals, same, I can go very easily. But having the same problem at the same time with the two resources that are interacting together may become a problem, and that's why I become a bit skeptical about this. Maybe we can go to next slide. Okay, so finally, what is the tension? What could be the tension here? Of course, we have talked about this geological and energetical issue potentially, and of course this makes the reserves vary, etc. There are also other questions like the concentration of production. I'm sure you've heard about this rare earth in China or cobalt in Democratic Republic of Congo, etc. So there are many different things. Basically, this is okay, and sometimes on internet we find some fake figures like in 28 years we will be out of whatever, zinc, copper, or what, I don't know what. In fact, of course, you understand it's not working like that, because the reserves will vary. Generally, they will increase. But you have also on the demand side, not on the offer side, on the demand side, you will have first a certain growth. So of course, you have, if you divide by the current rate, it's a bit, you miss the growth effect, which is of course very important. On the other side, you can have also a reduction of the demand by the fact that you can substitute some metals by others, and it happens. There is some kind of developments, industrial developments. When a metal becomes too expensive, then of course the industrial companies have an interest to develop alternatives. And you have also the recycling rate, of course, which is very important. So maybe let's have a look, Cathy, to the next slide with these different items. And this is the first item is the growth, and you can see how impressive the growth, of course, has been on metals. You have to understand that there is no dematerialization of economy. There is no post-industrial economy. Maybe we think in UK or in France, or maybe not in Germany, maybe because they have become more industrial than us, but at a global level, we are increasing the extraction of all these metals at a higher growth, with a higher growth than the GDP. The GDP is about 2 point something percent. Then we are a bit able to make uncoupling with CO2 emissions. The CO2 emissions, they grow, but a bit less than the GDP. But for the metals, it's the contrary. They grow, their extraction is growing faster. And you can see here how impressive, of course, the industrialization, the urbanization, the motorization of course, of emergent countries, China first, India behind, and the rest, which is creating these impressive levels of production. And for the specialty metals, no, you can keep, Cathy, that's perfect. That was for big metals, and for small metals, it's sometimes even more impressive or steady in terms of growth, because you have all these new applications, like you have indium, for instance. The tin indium oxide is the only transparent and with a high electricity conductivity. So in every touch screen you have them. So when the touch screen developed, it's climbing very fast. Cobalt is used more and more in the batteries, etc. You have many different types of growth reasons, let's say, for all these metals. Then we can talk about the second item, which would be substitution. Okay, we could still say, okay, sometimes maybe you read this, that you have okay, maybe we could have a problem of shortage on cobalt, and we can have enough cobalt for all the batteries of electric cars. And then you have always people saying, yes, but then we will make batteries with other items. Yes, for sure, why not? But you can see here that there are some metals which may be difficult, very difficult to substitute, because we have just no reasonable substitute for copper, for all electricity. Not really reasonable things for nickel and chromium. For stainless steel, of course, you can still paint your steel if you want to battle against corrosion, but it's not so easy. You cannot make soldering without tin, and it's including the soldering for electronics on electronic boards. Catalysis without platinoids is extremely would be quite difficult. If you want something very hard, so tooling to drill oil wells, or to put to make a hole in your own house, you need some kind of carbides with tungsten, etc., etc. So we are a bit dependent. Of course, sometimes you can say, yes, there can be some wind turbines without rare earths. That's true. So you always find that against a certain tension, you can have some kind of options, and generally you have we have been developing the utilization of all these different metals, because it's optimizing. So if you reduce a little bit the optimization and the performance that you are asking for, then you can substitute to a certain extent. For instance, there is tantalum in the micro capacitors, or in all the smartphones, etc. And you can make capacitors without tantalum. You can do it just with aluminum and paper, and it worked like this in the 70s and 80s. But then your smartphone is not a smartphone anymore. It's a brick, which would be very much bigger. So you have to renounce to some kind of performance if you want really to substitute. And then the third, of course, item, Cathy, we can go to the next one, is recycling, of course, because I've been comparing with you all these questions of oil and gas and metals, and saying it's working the same, etc. The reserve, of course it is, but there is an enormous difference between oil and copper, because oil, once you have taken it out of the earth crust, you burn it and it finishes in the atmosphere with various problems, by the way, we know. But of course, copper, once extracted, we don't burn it or lose it. It's just there, and then we are going to use it in our human sphere, on our technosphere. It will be there as a stock, and it's all around us in our objects. So the idea, which is so different, would be to go to circular economy, of course, and to say, okay, metals, we have the chance with the metals that they are extremely well fitted for circular economy because they don't lose, like some plastics, like all the plastics, by the way, they don't lose their capacities. They are their technical characteristics. You can always take a cable, a copper cable, and make a new copper cable, no problem. So here it's just an example. You know that this king used to be quite famous because it's now in Turkey, by the way, and the Pactolus was quite rich in gold, and maybe you have around around your neck or as a ring, you have a little bit of the gold of the Pactolus. I think not, because of course the exploitation has been quite exponential since, and probably the gold you have in your ring or in your necklace is more coming from South Africa, or maybe if it's a bit ancient, for California, but probably not from the Pactolus. But it's just to say that, okay, today maybe we think that about 90% of the gold that has been extracted by humankind since the beginning, since let's say 4,000 years ago, 4,000 years ago, is still around. Of course, not in my home, maybe in yours, but or in the banks, but it has not been all lost, because of course the recycling is quite high, and it's very easy to see that it's gold and to take it away from the objects. And where are the 10 last percent? The 10 last percent have been launched in satellites, or have been lost in galleons, in Spanish galleons here and there, or have been used in electronics, and where they have not been properly recycled. So if we move from gold and go to the next page, in fact, the problem, I'm sorry for the illustrations which are not fully Apple compatible, I think, but that's not a problem. So there are two big limits to this circular economy, and actually there are very strong limits. The first limit is the dissipative usage, the dispersive usage. In fact, we don't use all these metals like the copper cable. Some of the metals we use as chemical products, we use in paints and dyes, in inks, in cosmetics. So the biggest example is titanium. And titanium, 95% of titanium is used as titanium oxide, which is used as the dye, the universal white dye. And you find it in your toothpaste. You find it in solar creams. You find it everywhere. Here you have the example of copper that is used in organic grapefruit growing. It's the only copper sulfide is the only one which is authorized to kill the mushroom, etc., etc. So this is quite a big limit. Of course, titanium is a bit an extreme example, but let's say that depending on the metals, sometimes 5, 10, 15, 20% are used like this. So if you want really to be ecological oriented, you should print all your papers, for instance, in black and white, because if not, there is a quite good chance that there are chromium for the greens and the yellows, or cadmium for the orange, etc., etc. Well, this is one limitation, but there is a second limitation which is even bigger in the effect. And this limitation, and we can go to next exactly, is the downcycling. In fact, the problem is that all these metals, even if we can get them and they are not dispersed by the fact that they would be thrown away not in the right recycle bin, or not thrown away on agricultural soil, etc. They are used in plenty types of alloys, and there are really many. And there are tens of thousands of different alloys, and of course there are not tens of thousands of bins. And they are just transformed like this. And just to give you an example of how we recycle a smartphone, which contains about 40 different metals, what do? We remove screen, we remove battery, and we crush. And then you will extract a little bit of gold, a little bit of silver, a little bit of platinum maybe. And if you are really in the best-in-class factories, and that is not finishing somewhere in West Africa or Pakistan or China in informal recycling processes, you will maybe get 10, 15 different metals, but not the 40, because it's too small content and too much mixed in the object, and then you cannot put anybody to unscrew and to try to sort all the different little electronic parts. You cannot do that, because there are only €2 of value of all the metals in a smartphone, and €1 is for the gold of the microprocessor, and then €1 for all the rest, and it's not worth. And then we are not organized for that, so we are wasting very much the thing. And another example, that when you go for the recycling of the car, what happens? You remove the tires, you remove the glass, you remove maybe the seats, and you crash. And you remove the battery, sorry, first, and you crash. And then what happens? Then all the copper cables, all the small metals that are used in the small engines to make all your all these automatic moves of the car, etc., they are crushed with the steel, and they are recycled as steel. So it has not disappeared, of course. Nothing disappears, was saying the chemical specialist Lavoisier at the 18th century. Everything remains, but it is lost because it will become a bad recycled steel, which will be used mainly in construction. And you will never get back your copper atom or your neodymium atom or whatever you want to again be used as a neodymium or as copper. So you have a big downcycling, and it is a very important effect. And maybe I give you this study which is a bit old now, about 90. Sorry, yes. So this is the real recycling, the virtuous circle of recycling, and this circular economy. We have dissipative usage. Then, of course, sometimes we don't recover everything. I think we could find quite easy examples of what's finishing in your bin and you don't get everything. Then you go to recycling, but with a certain downcycling. And then finally, there is some kind of recycling without downcycling, when we can really reuse the metal. Well, there are good examples. For instance, lead, which is used in car batteries mainly, is recycled maybe at 99%. Very good in European countries, because it's quite dangerous, because it's used almost only in batteries, and it's very easy to recover, to organize that, and then the recycling is quite good. But there used to be in the past a dissipative usage, by the way, when it was used as a white ink, as white paint, but not anymore. So this is what happens really. And of course, this depends on, for every of the 60 metals, there are different percentages. And here, maybe Cathy, if you push on the button, there will be an example of what happens. And yes, the colors have not changed too much. And you see in the red that about 20 metals are recycled at less than 1% at the worldwide level. That means, in fact, zero, actually, all the rare earth, but also some emblematic metals of the electronics, of course, because of the effect I was describing you, like gallium, germanium, indium, tantalum, etc. All these things that are used in very little quantities in many different types of objects that are not properly treated at recycling rate. And of course, next page, Cathy, is that with this bad news, it's not just bad news of today, it's bad news of tomorrow too, because when we come to these smart solutions, in fact, we talk about accelerating these issues, not breaking it. If you go for a clean car, what is a clean car? It's something that is more or less going at the same speed, but you need that the weight is lower. So you make better and better alloys that contain more and more types of little vanadium, tungsten, whatever. When you go to smart cities or smart building, you try to fight the CO2 emissions by enriching technologically the building. You put captors, you put sensors, many types of things, and you enrich you use more and more resources. So we are trying to treat maybe one parameter, of course, which is very important, climate change, and so you try to reduce emissions and optimize things, but without changing anything else. You start consuming more resources that will consume more energy, that will also emit more CO2 at the end. Of course, this is only the start of the story. Maybe Cathy, next page. We can think about IoT, we can think about 5G, we can speak about putting more and more robots, artificial intelligence, etc. And this is really the trend towards a higher and higher consumption of resources, and we get, instead of going close to the circular economy, we are just going far from it. And that's why I came to this low-tech thing, of course, and we can go to the next page, Cathy. And this low-tech page story, of course, it was just at the beginning like a provocation against high-tech solutions, saying, maybe no, it should be low-tech. And here, maybe you recognize a little bit of COVID-19. It's just just to make a rapid eye movement on that. Well, in fact, of course, we are very happy about high tech, especially medical things, and when you have to go to the hospital because of it. But most of our response at a human level, at a humankind level, at a worldwide level, has been furiously low tech. In fact, it has been about blowing your nose or cough in your elbow. It has been about wearing a mask. It has been maybe sometimes homemade, by the way, when we were waiting for a mask. And it has been also about staying home. So it was more about the behavior than the technological solutions. And maybe this is something that we should keep in mind, that we should not be always high tech in our response, because it's going far from the resilience. There are also plenty of other bad possibilities that it's not only about resource consumption. We could think about, I don't know, IT viruses. We can think about very different fragilities there. But at least we should think that in many of our products and services, we could think about reducing the richness of the technology and the resources rather than making it higher. And here, finally, for me, the low tech is not about saying, okay, I will make a solar cooking, but it's more about like an approach. And the approach is about asking three questions, and which is why? Why shall I produce a service? Why shall I produce a product? And then the second question will be what shall I produce? And the third will be how. And I will try to just make a few first thoughts about these three items. So the first one is the why is in fact the question of the sobriety, of the frugality. So there is no clean car, there is no clean energy. It's not possible. You have always something. You have an impact. The impact can be lower, of course, than an oil car, maybe, but there will be an impact. Nothing is never clean because you use resources, and just by driving, even if the car would be absolutely with zero energy, or then you need anyway resources that will be badly recycled. You have even the tires. The tires, they contain cobalt, they contain zinc that is just weared on the road at every kilometer you drive. So there is never anything clean except what you don't do, which is a bit awful. But so we don't say that we should stop living, but if we want to reduce the impact, we should first think why do I need this? What should I need? And we should put this always in front. It's what I call the ecology of demand rather than the ecology of offer. So what do I really need? So here are a few examples in different sectors about the cars. Of course, the best would be biking for sure, but we all know that we cannot, not 100% of the population can bike tomorrow. We have organized our towns, our lives on a different way. But first, we could do lighter cars. We could do less powerful vehicles. It would be so easy. Today, the cars are more and more efficient, but there is a rebound effect, which means that the cars today are bigger, are heavier, and they consume more and they emit more. It would be so simple with the current technology to reduce the car by, I don't know, a factor 30% or 50% in terms of weight, and speed limit reduction, why not? And then we would really win this very easily. It's just like this. It's just a regulation, or you can tax per kilogram or whatever. Yeah, there are plenty ways of doing this. What about buildings? Of course, we should build greener. Of course, we can build in wood. etc. But first, we should build less. We will not build as much as today, only with wood. The forest will not be enough. What we have to do is to use better the buildings we have. In France, for instance, the schools, they are not used during the weekend, during the vacation, during night. We should open the schools for other activities, multifunctional buildings. There are plenty. Our heritage, our patrimony is enormous, and we could do that. And then there is another point. We should insulate, of course, the buildings. But first, before insulating, you can lower heating and insulate your own body before insulating it's much more rapid, much more efficient. And of course, it is a different, it is a cultural change to a certain extent. But for the moment, we do the way on the other way. That means the cultural change is we increase the number of degrees we have in our apartments, etc. Same for the consumer goods. We should go for many, reduce the disposable objects, etc., etc. Internet, there are plenty of opportunities. We could reduce by 99% the ecological impact of the digital world. But for this, we need to reduce the video, to have less mobility for certain types of activities, etc. There are plenty of roads here. I cannot enter in all the details. Maybe we have been trying to express in a right English with Chris in the book, but there are many things. Agriculture, of course, less meat is a very good example. Once we have done everything we could about sobriety, then yes, comes the question of what shall we build? And then that's the second question. And here, of course, keeping in mind that the recyclability is a very big challenge. And of course, the best way is to make them repairable, to make reusable, and then, of course, to make them easy to dismantle and avoid a certain kind of metallurgic incompatibilities, because there are some also. And then always try to change and go for robustness, simplicity, single material rather than combined materials. Try to avoid rare metals, avoid sometimes electronics. I mean, okay, I've taken this of course, a full example, because of course I can imagine that the bottom right device is also much more practical than the other one, but we should think always about making some kind of techno discernment. Where should I use rare resources for which devices that are really necessary, and where finally I could do it a bit differently with a different organization. And then comes the last question, and I will not enter too much here, but there are many things to say also. It's the how. Once I've decided that finally, okay, I want to wash my clothes, it's quite necessary. Of course, I could stop washing my clothes or wash it only once per month, but then you have a kind of cultural change to put in place, especially in the subway. But okay, let's say that I keep a washing machine because I don't want to go and make it by hand. Okay, then the question is, how is built this washing machine? And there are things to say about the fact that we are in a fiscal system, we are in an economical system where we say, super, I make more and more productivity. That means I product more and more with more machines and less human work. Fine, super, less expensive. But then we have to understand that the productivity, it's machines, and machines, they use resources and they use energy, and they consume resources forever, because a part of these resources will be lost because they will be badly recycled. So where should we put the right machines? And I think, for instance, in agriculture, I don't want too much to go into how we say in Chris, I don't know English, to make all this stuff about wheat and so on, only without any machine. It would be really, really painful, of course. So maybe we should not demechanize the agriculture, but in many other areas, think about your daily life, where we have machines, distributors, I don't know, and more we will have, by the way, softwares and calculators in data centers, just to replace people who have no work. It's really a stupid world. Okay, so I come to the conclusion, and I think I've almost stuck to the timing. I'm really proud of it, and maybe I need to also open the lights. I will do it in a second. So green growth will not make it. the gap is too big. We will be stuck by, I don't know which resource, how, why, but this will come at a point of time. Maybe not in 1 year, maybe not in 10 years for sure, but at least somewhere between now and 1 millennium, maybe, let's say, to stay calm for tonight, there will be a problem of resources. So we have to work on demand and not just on a cleaner offer, because the cleaner offer is consuming more and more resources and more rare resources, by the way. So don't ask, I'm an engineer, and I don't know if there are other engineers in the audience, but don't ask engineers to make miracles. They won't. There is always a price to pay. There is nothing clean and great. So there is no exit by the top saying, okay, for sure there will be still technological progress. For sure there will be still innovation. The problem is that for the moment, this innovation, these smart ideas, we need them. Of course, nobody says that we have to come back to the caves or to the Middle Age. Of course, we have progressed very much since, and that is great for that. But we need to find a way to orient innovation towards resource economy, and we are far from that for the moment, because we orient resources mainly on human work economy, and that's not the way to do. And maybe one last slide to open the discussion. Don't know if you recognize him. It used to be our president. Okay, just to give an example of a small robot that is used in now, I think in Japan, in some old people. It's for old people who are alone, so they speak to a robot. It's a bit stupid. Maybe I don't know if you know we say bikini also, Chris, in English, or okay, the swimming suit, and it's a connected swimming suit that it has a UV captor, and it tells you on the smartphone that it's time on the beach to maybe to change the side, because you may have a problem if you don't put some solar protection cream. And the last one is a kind of virtual reality headset. This is not a real one, but this may become a real one. So you see that we can imagine to have a chicken growing in very small cages like today, but to avoid that the meat becomes stressed, they feel like being in a nice countryside. And it used to be a design. It's a design university professor who made that, but for real people are really working on that. I've seen the same device, a real one, in tests on a cow. They even think about this for, I don't know, rhinos in the zoos, to avoid that they become a bit that they need a psychologist. But okay, anyway, this kind of and there's the last one is a device, maybe on the bottom right, maybe, I don't know if you know what it is, but it's a distributor, it's a food distributor for cats, and it has of course, you can weight your cat, and you can follow his weight on your smartphone when you are far from home, and there is a camera to recognize your cat, to avoid to feed all the cats of the neighborhood. Of course, it would be a bit stupid. So this is about $199 on internet. I don't advise you to buy it, but is it the kind of word and the kind of innovation that we want, or shall we do it differently? Thank you. And I'm gonna go 1 second for opening light, because here we are.
Thank you very much indeed, Philippe. And I think some of those listening to you just now will wonder why you needed anyone to translate the book. You could have done it yourself with your English, I think.
Oh, you joke.
Thank you very much indeed. I've been watching the chat, and I've got at least half a dozen possibilities for questions here. Some of them may have been addressed already, but I'll ask the people who have posed them anyway. I think the first is Ian. Yours was the first comment about decreasing entropy, an important component of a shift. Has the question been answered, Ian, or do you want to make a comment now?
Yeah, well, thank you very much, Philippe. Indeed, I think you have answered the question quite a lot. I asked that quite early on when you were sort of talking
Yes.
about resources and the depletion of them. And this has been a bee in my bonnet, as we say, for a long time. This whole problem of we're making smaller and smaller things, and obviously small is beautiful, but when you end up with your smartphone, as you say, little with got a huge number of components in it, all of them tiny, it becomes increasingly difficult to sort of reverse that process. I put a proposal together a few years ago for trying to create a recomposition center, as I call it. The first title was a decomposition center, but that didn't sound too good. So I went for the word recomposing materials. And this is, it's something that, a huge amount of what you said makes so much sense in that framework of stop mixing things up in the first place. If you do mix them up, then design them so you can unmix them more easily, and even down to products should have a description with them. They should have a QR code on them which allows you to look up how do you decompose this, how do you get the materials back out of it in the best way. And then after that is a sort of, we really need to put a lot more effort into researching how to unmix things. And that's really what I was trying to promote in that idea of mixing it. I was also actually really taken by a little section in your book that says, the delicate question of returning nutrients to the soil. And this is an area of also great interest for us in the Institute at the moment, looking at the waste streams, and particularly food waste. Mm-hmm. And so much of it is, in a sense, capable of being dealt with at the end of the pipe. But because it's been mixed up so much with so many nasties, the process is almost impossible. So whereas, you might think you just collect the sludge that comes out at the end and put it back on the land, you can't do that because we've mixed so much into it. So I was really taken with that. But
it's mixed with the dispersive usage of the toothpaste and so on. So yes. with many chemical components, including some metals, actually. Yeah.
Absolutely, yeah. So I certainly wholeheartedly agree with so much of what you say in your book, and if there's anything more you can sort of add to how we might be able to move forward with recomposing materials, I would be delighted to know. Thanks.
Yeah, there is one point, and especially for this question of electronics, you're true, this small is beautiful versus small is recyclable could be a yes. Good question. I think nobody has been able of has taken the idea to see what would be the right balance, because finally you have also many people who say that, yes, thanks to technological progress, we have been using less and less quantities to produce more and more services. So there is an enormous efficiency there, but there is also this rebound effect that makes, when you are more efficient from a material point of view, you are also more efficient from an economical point of view, and then that means that the price is lowered, and then you can consume more. And it is what is typically happening in the IT industry. I mean, the progresses are enormous, and for instance, look at what is the cost of storing some information on the cloud. I mean, it's becoming peanuts. But then, because of that, we multiply by 2 the quantity of bytes that we are producing. That I think every 18 months, something like that. So it's really an exponential curve, which is really impressive. And of course, that means that at the end, the total consumption of the IT world is increasing despite the impressive technological progress. I think that before saying how should I be able to split again and split the components and get them again, I think the first thing would be to make the objects last more. That's the first question, because I maybe I could show you. I have an enormous electronic board, this side, which comes from I think 2 weeks ago from my heating machine at home, and there was a problem. Something, I think probably only one small component was wrong, but there is no other choice, another process than just changing the full board. And why? Because you need the knowledge, of course, and the guy who comes says, okay, my basic and standard thing is to change the electronic board. I order a new one. You have it in 2 days. By the way, it's cold, so it's good to have it in 2 days. And they change it like this because the cost of all the material, and when I say the cost, it's the cost of extracting, the cost of all the production of the different components and soldering everything on the same board, plus maybe the little cost of the pollution, which is peanuts, because we pay peanuts for pollution. We just pollute, and there is enormously lower than the cost of the manpower of the guy who would spend maybe he could have the solution to say, with the right, I don't know, test machine and so on, and a small solder, he could find a way to change only one component. Maybe this component is only available by 100 or 1,000 somewhere in China on Alibaba website. But maybe he could, but maybe he would spend 1 day. And who will pay this 1 day? So my feeling is that you cannot really define. I would say that let's use the efficiency of the system today. And today the system efficiency is focused towards productivity because manpower is too expensive. And I think that's one of my ideas, but I'm not the only one to say that. It would be to say, let's transfer progressively, maybe, but quite rapidly. Let's shift all the money that we put on the manpower, on salaries, to pay pension funds, to pay unemployment, to pay, of course, all medical care, etc. All this is put, at least in France, but I think it's the same in the UK. It can be private, it can be public, but at the end it's the same. It's put on the human salary, on the human power salaries, human work. And peanuts is put on resources. So it's always better to arbitrate towards throwing away, because if my iron, I always say a ferro repassé, my iron one is going down, and then it's like my heating machine. I will go to my best dealer and say, can you repair? I say, oh guy, for 30 euro, I need 45 euros just to open it and tell you how much it will cost to repair, even if it's peanuts. And 45 euros, you get a new one made in China or made in Romania. So I think that shifting from the human work to resources, to CO2 emissions, to pollution, to resource consumption, this kind of thing, really changing, having a kind of fiscal shift would help to go for an economical system that would help making objects last, being able to take care, to repair, and then of course there will be also, I suppose, some progress there. And maybe you've seen this Apple who is a bit challenged about that, and like Google, they are a bit in advance. And have you seen this robot that they show that is supposed to unbundle all the iPhone? And of course, they claim that with a small robot, they will be able to really optimize the recycling of the iPhones, because they will be able to not crush it directly, but to be able to dismantle before crushing. And of course, I think it's just marketing, because the robot itself will have to be dismantled too, and it's creating its own thing, So I think it's a bit putting problems on problems. But so I would say yes, probably taking this going to a more repairable and long-lasting objects world would need some fiscal adjustments.
Thank you very much. The next, there's a number of comments which I think we can broadly group under the term degrowth. John Blewett, you were, I think, wanting to ask something about that. Would you like to say something, please?
Yeah, I think degrowth, the word degrowth is 3-4 times in the book, I think. So I've not, yes, of course, I am for degrowth, no problem, for sure, in whatever the definition of growth today is. I mean, reducing emissions, reducing material consumption is degrowth. I don't think growth is anywhere possible. If we want to put growth, let's take 2% of GDP growth. Okay, let's imagine that. What does become this GDP? After 37 years, it has doubled. After 1 century, it's multiplied by 7. No problem, we've done that. Of course, we've done even more in the past. After 2 centuries, it's multiplying by 49, 7 times 7. Okay, super, we've done that too, no problem. But after 1 millennium, it becomes multiplied by 390 millions. 7 times 7 times 7 times 7 times 7, 10 times. How can we believe that in the year 3020, in 100 years, 1000 years from now, we will have the GDP of UK multiplied by 400 millions, and at the same time, the CO2 emissions divided by 4 or 6, let's say. So that means that every pound of GDP would be 1.5 billion more efficient than today. Who can believe that? No engineer for sure, maybe an economist, I don't think so. So anyway, growth will end, whatever happens, because even if we would continue in 500 years later, if we do that, we say that the GDP would be more or less correlated to the energy, which is for the moment the case. Okay, so we could say, okay, let's go for renewable energy. We have plenty of energy from the solar system. Great. In 1,500 years from now, the humankind would need the power of the solar star.
Yeah.
Not from the sun coming today from the solar star itself. Of course, we could invent maybe fusion, okay, nuclear fusion, but we will never do reactors that are the size of the sun, do we? Of course, it's stupid. And then, scoop, 37 years later, you need 2 stars. And 31 years later, you need 4 stars. That means, you make the calculation, that you need to invade the full galaxy more rapidly than the speed of the light. So it's stupid. Growth at a point of time is mathematically stupid and physically stupid. So yes, I do believe that growth will end. And the more the more rapidly we organize for that, we invent, let's call it a post-growth system, where we can still, share, let's say, revenues and so on between older people and kids and whatever. The more, yes, we will have to do that. I don't know when, but
I'd like to take a question out of sequence. So somebody just posed a point. Hugh Atkinson, you make a point about degrowth, and it's one that we heard in the Schumacher Institute when we had a Labour Party politician visit us the year before last, that there's a problem with the term. Would you like to say something, Hugh? Are you able to hear me?
Hi, yeah, I'm here.
Yeah,
Thanks.
perfect. Yes.
Very interesting. I wish I'd had better science teaching at school. I might have understood it even better. Thank you. I just think that degrowth, it's just, I see what it means, but it's too negative, isn't it? It's if we're going to sell the idea of a better, more sustainable world, we need to inspire people, and I don't think that inspires anybody. I think well-being, maybe that's not enough, but maybe we need to get our collective heads around better language on this.
I do agree. I do agree with you that degrowth is probably not the best marketing word for politics. And by the way, it's where I have my limits. I'm only a poor engineer, and I'm not a psychologist or an anthropologist or sociologist or things like that. But I do agree. And but the problem is why is this word so frightening? It's also because we have linked since 70 years, let's say, growth with employment, growth with richness, growth with happiness. And even economists, you know this curve. I'm sure that when you get out of misery, yes, sure, growth is great and you are getting happier. But then at the point of time, after a certain revenue, more or less, I think the revenue per person of Portugal, which is much lower than UK or France, then you have a kind of peak or limit in the happiness index, let's say, whatever the GDP per person. That means that the average Qatari is not happier than the average Danish, let's say. Huh? And we know why, because happiness, of course, is something else than GDP per person. GDP per person is useful at a certain point of time, and then other things come, like what are the inequalities level, what are the perspectives for your kids, many different social interactions, etc. And so there is this first thing that's okay, just growth for growth. The only thing now is that we live in a kind of unemployment world, at least in a certain number of countries, or people are at least scared to lose their job sometimes. And as far as we have said, yes, if we have no growth, we have an economic crisis, then of course people are for growth. That's normal. So that's why I said we should invent another system which could be compatible partially at the beginning, at least with capitalism, because if not, it would be even more difficult. But and there are some strengths of capitalism, and the strength is the strength of innovation, at least. But the question is how to put the strengths on the right way. I think that yes, inventing something like a post-growth thing would be interesting, and I think even growth is becoming, at least I see the debate in France, is becoming a bit tricky sometimes. Look, for instance, about the growth of cities. I'm living in Bordeaux, and the growth has been impressive because the high-speed train has come a few years ago, and everything is getting more expensive. There are many traffic jams, etc. So growth is not always and in every circumstance a synonym for happiness, by sure. But at least at let's say economical and political debate at let's say at nation levels, it's still a magical word. But I think this will change too. So I'm not sure I agree with you that degrowth is the right term to win elections, for sure. But I would say that if we say going for a more sober and resilient system, for instance, resilience, I mean, it's becoming a magic word now after this COVID-19 thing. So look at the smart city. I don't want a smart city where the water in my house will be defined by South Asian sensors with data which are captured by a Californian company and stored in Greenland by another data center company, and that could be virused by anything, and then I have no water at my no tap water anymore. I mean, this is also this question of resilience is there. We have been to a hyper industrial world, which is becoming very complex.
Thank you very much.
John Blewett has a couple of points he's made in the chat regarding this. And John, do you want to say anything, please?
Yes, I completely agree with Philippe, and my view is that degrowth is a reasonable word, because what is important is to get across the idea to everyone, really, that growth is utterly destructive, and as such is actually a negative, ecologically speaking. So if degrowth means reducing our consumption of materials, then I think we can work to ensure that people understand degrowth not as a negative, but something as quite positive, the reduction of our usage and increasing the quality of our lives, and ensuring that we have a good future for our planet. So I think it's a question of how the word is used, and I think that's what we need to concentrate on, not trying to find another word, but re-articulate the meaning of the word which is quite now well established.
Yeah, thank you, John. And I see also another John who says it could be about an arrived society. There has been also some thoughts in the 19th century with John Stuart Mill, for instance, saying, talking about steady state economics. Okay, I don't know exactly how to make this progress, but I think that more and more people see a difference between the promises, and which can be political promises or technological promises, and the real results. And if I look at, for instance, this Uber or different companies talking about autonomous flying taxis. I mean, just remember that in the 50s there were already some newspapers saying that there would be everywhere nuclear flying cars, and then in the 19th century you can also find a beautiful prints with exactly the same flying devices. I mean, no, they will never come. Let's stop dreaming, or let's dream at the right things. And I think humankind needs to dream. We are dreamers since the beginning, and we will continue to dream, and we have to dream. But we need to dream about something else than technology piling.
Thank you, Philippe. There's been some other comments, and I have one eye on the clock, and we're just coming up to the end of our time. But Adriana and Connor in particular were making comments about the opportunities of standardization, of perhaps rating systems, the opportunities for regulation, and so on, design. Could I invite Adriana first? Would you like to say anything?
Oh, hi there. Hi, Philippe.
Hello.
Yeah, I wrote some really bog standard comments. You can see them later. So I have a much more interesting thing I want to say, I think. So it goes back to something which I was very drawn to, what you said, about the way the current system values the manpower to fix things and the value of material objects. And for me, I thought I have contemplated this, and I see how this might incorporate an answer to this growth word. So, because we come from a scarcity mindset, I think possibly that the idea of growth is this aspiration from a scarcity mindset. So growth has become an ideology. It's not just a word, it's the way we live. So going back to what you said about valuing the human above the material, and also because growth, underneath growth is what you also inferred, which is about employment. And this is something we are all engaged in. We all need to have understanding of employment. So I wondered if we could replace the idea of growth with something that indicated a trajectory away from the valuation of materials above humans, because this would have ties to all of humanity. And then it would automatically change this kind of idea of GDP, which we have to get away from, into something which is about an investment in humanness. And it will just flip a lot of switches on the way down.
Thank you, Adriana. I think, yes, I can only agree on this. I think that there are from time to time, and probably in a certain good number of cases, the machine works better, or let's say being helped by a machine is useful, and we should not renounce to that, because I don't know, you can imagine that I don't know, maybe an assistant robot for surgery could be very interesting and more precise for very small operations, and will help the surgeon to make a great operation.
Yeah.
In this case, it's fine. But there are many cases where technology is just replacing a job, for sure. And maybe it was not a super great job. I don't know if we talk about what is the first use case of the autonomous car. Obviously, if you want to pay the extra money of the autonomous car, because you need to pay it, it has a cost. It's because you can replace the salary of a taxi driver or a bus driver or anything. So, and we are in this. For me, we are in this system of the 19th century, because in the 19th century, the resources were costing nothing. In fact, it's still today, the resources cost nothing. They just cost the salaries and the capital you need to put to invest to extract it. But except this, it's free. And in the 19th century, resources are really free. There is plenty, no problem. Even here in Europe and so on, the mines are there. And on the contrary, human work was really seldom. It was difficult to make people work in manufacturers and in mines in the 19th century because they didn't want. We had to force them sometimes, maybe with the enclosures in UK and with other types of possibilities. And you had strikes and people, of course, it's really not. So all the system has been put to replace more and more human work by machines. Of course, on the beginning, maybe also for the power, it's quite useful, of course, to avoid horsepower or manpower, but then now we have come maybe to a stage where it's not so useful, and yes, putting humanness in front instead of material is for sure something that would change very much the way we take decisions, at least.
I don't think I was very clear when I was speaking to you. I understand what you're saying, but I think I didn't make myself clear. So, so that it's a philosophy. The idea of GDP is a philosophy, and one of the key words is growth. So, by re-understanding the system of GDP, which is not about the corporatization of life, but which is the investment in humanity, in the stripping down of objects, because to strip down objects, it's an investment in humanity. Mm-hmm. So to not just to change the word growth, but to re-understand a mechanism which would replace the idea of GDP.
I do understand, but the debate on changing the GDP as okay, first as an indicator, and behind that as a system, let's say, I do understand that, but I don't know if it's not the north face of the mountain to climb. I'm not sure, but problem that the GDP is not about just saying, "Oh, I'm happy the GDP is 1.5% this year."
Yeah, the
GDP is an important indicator. Why? Because behind that there are the debts, the state debts, the public debts. There are the enterprise, the company's debts, the private debts, etc. And all this is indexed on the GDP. That means if the GDP does not grow, UK state will get bankrupt next year, and same for the French state, and same for many other public or private companies. So growth. In the book, I write a few paragraphs about that, but we would go too far tonight for that. But I think that personally, I think that just borrowing money with an interest rate obliges you to grow, because to reimburse and to pay the interest, you need to have a monetary mass growing, and to have a monetary mass growing means that you need to increase also physical exchange.
Inflation.
Yeah. Okay. It could be only inflation, but then why borrow?
Always only inflation.
Yeah. Then I don't borrow. Then I don't give you any money. I don't care because you will just reimburse me the same amount. No, I want more than inflation normally in a right system, because if not, I have no incentive to borrow money. So I think we would go far about this question of growth. So my way is probably a modest way to just say, okay, let's look at the technological part, which is not matching and not working. We make too much promises there, and it's right. And of course, then there are, to make this happen, to make this repairable world and long-lasting world, we would need to change economic parameters for sure. But maybe we would go far. Maybe, let's see.
I think that's I think that's a very good point at which to stop. We have come to the end of our time. Very interesting discussion. Thank you very much indeed, Philippe. Thank you very much to all of those of you who have asked questions. I'm afraid we haven't had a chance to let everyone ask them directly, but if you have a chance to look at the chat, there's some really interesting comments that are made there. Those who have attended, I hope you think this has been worthwhile. I've been very pleased to hear your comments, and thank you very much to the Schumacher Institute for hosting this. And if you do get a chance to buy the book, it's not very thick. It's very easy to read, and Philippe is also, you can find a lot of what he has to say. If you speak a little bit of French, there's a lot of interviews with him and chances for him speaking online that I hope some of you may like to follow up. But in the meantime, thank you very much indeed, Philippe, and best wishes to everybody for attending.
Indeed.
Thank you.
Bye-bye. Brilliant. Superb.
Okay, Ian, thank you.
Thanks, Chris.
Thank you.
Excellent. Good stuff. Take care of yourselves.
Yeah, and you.
Yeah.
Anyway, Happy New Year to you. We've already said that. And thank you, Katie, for the slides worked very well.
Yeah.
And thank you, Philippe, if you're still there. That was very good.
Yeah, thank you, Philippe. And thank you, Chris.
Yes, I'm still there. Thank you very
still
much.
there.
Okay, it was not too stressful to help me, but it was really useful that I don't need to push and to see the people, because I need to see a little bit people hearing me. So great. Thank you very much.
Yeah.
Still got a few others in the room, but yeah, apologies for the slides being slightly.
No worries. No worries.
Yeah, I don't know what happened there. It's my
just the colors have changed a bit. That's not a problem.
The open office for you. I'm not with Apple.
Well, see you soon. Chris, you've seen that I've sent you something. Huh?
Yes, yeah, I've contacted BUP already, and they don't know about it, but they're going to follow it up and find out.
I know, yes, I know. I was thinking about the article I've wrote.
Oh, yes, yeah. I saw that other one. Yes, yeah. I'd be interested.
It's not a hurry at all. Yeah, sure. Okay.
Okay.
Super.
Okay. Look forward to speaking to you soon.
Yeah.
Ciao. Bye for now. Thanks. Bye.
Cheers, folks.
Cheers. Thanks, Katie. Bye for now.
Bye.
Bye.